Hello everyone, my name is Mykhailenko. I am going to talk about economic aspects of introducing pumped storage hydroelectric power plants into the mine dewatering system for distributed power generation. Improvement of energy efficiency in mining production aims to enhance competitiveness of Ukrainian enterprises on global and domestic markets. Introduction of additional generation facilities into the enterprise power system is able to reduce costs when purchasing electric power from external distribution operators. Technological facilities located directly in or next to mine workings can be viewed as a method of producing power. The mine water drainage system is one of such facilities, and its energy potential is not currently used to the fullest. To increase efficiency of an energy resource, a mini pumped storage hydroelectric power plants, mini PSIHPPs, are suggested to be installed in sections of mine water drainage. Thus, mine waters can be discharged backward either from upper horizon or surface to lower horizons, thus generating power via hydroturbines. Efficiency of introduction of mini PSIHPPs for combined power supply of mine consumers is considered by taking water drainage of Rodina mine as an example. When conducting the research, three designs of the distributed generation system via mini PSIHPPs are considered. For each system design, a comparative analysis is performed with two options of power consumption considered. First, from the industrial power grid supplied by the external power system. Second, combined power supply of the grid and mini PSIHPP. The net present value NPV of the system and levelized cost of energy are used as a criterion for comparing efficiency of the above two options. Computational experiments are conducted by using MATLAB. Calculations of the mini PSIHPP's option considers investment for purchasing a hydroturbine and various expenses for scheduled and preventive repair and maintenance works. Power generation of mini PSIHPPs is performed at the nominal hydrostatic pressure. The cost of power received from the power supplying company for first category industrial non-household power consumers. Besides, power costs during peak hours are also modeled. The service life of the system makes 25 years, with the nominal discount rate is 8%. In the figure, there are NPVs of the power system for different conditions when basic power tariff is used. The graphs indicate that at low power consumption and hydroturbine flow rates close to the nominal value when Q equal 0.23 cubic meter per second and minimal power consumption, the NPV of the system is determined by operating cost of the mini PSIHPP. This is due to the fact that the power generation of hydroturbine fully satisfies the current power consumption, so the purchase of power from the external power grid of the distribution operator is not carried out. Additionally, there is dependence of the NPV of the combined power system on hydroturbine water flow rate and power consumption. There are also determined application areas of parameters within which it is advisable to use a particular design. The area of effective application of combined power system with its own distributed generation facilities within the considered change of parameters is 17.2%. There are the most unfavorable conditions for modernization of power system, as their total indicates the lowest area of distributed generation applied making is inefficient. Application of the tariff for peak hours is expected to increase efficiency of the combined power system with a single hydroturbine-based mini PSIHPP on the 500 meter level. This is due to increased cost for power purchased from the external power grid at higher prices. At the same time, expenses for purchasing, maintaining and repairing a hydro generator remain unchanged as compared to the basic tariff. The dependence graph shows a more intensive increase in the NPV with increased power consumption and reduced turbine water flow rate. The application area of distributed generation system with mini PSHPPs increased to 19.6% compared to the basic tariff. At the final stage, efficiency of introducing the distributed generation system with mini PSHPPs on the 500 meters and 940 meter levels of Rodina mine is considered, as this option has the energy potential of water discharge from several mines. For storage pumps are investigated too on each level. The obtained data indicates that the NPV of the mine power system with mini PSHPP is growing significantly. Analysis of components of the NPV system with combined power supply indicate a greater increase in the fraction of NPV of mini PSHPPs in the NPV system. In this case, the level of power generation sufficient for PSHPP power supply is provided in all the cases except for middle and high power consumption and low flow rates. The dependence graph shows an increase in system NPV in the area of increasing power consumption. The optimal application area of the power system with PSHPP is 50.6%. With the peak tariff in action, the NPV of proposed power supply system with the mini PSHPP is lower than NPV of the system in which consumers are supplied only from external power grid with middle and high power consumption and high water flow rates. The dependence graph in figure shows a more intensive increase in NPV with increased power consumption and reduced hydroturbine water consumption. This significantly expands the application area of the distributed generation power system compared to previous case. It's worth noting that comparing the efficiency area of the system with 4 hydroturbines with the corresponding areas with 1 or 2 hydroturbines installed. This one appears to be the largest and make 72.8%. It means that despite high capital cost for purchasing generation equipment and its subsequent maintenance, this option is the best in terms of power supply with varied power consumption or hydroturbine water flow rates. Application of mining enterprises drainage systems are with hydroturbine-based mini pumped storage hydroelectric power plants of various capacity to producing additional power enables increasing efficiency of power supply to consumers by reducing the cost of purchasing power from external grids. This also reduces the cost of final products and increases their competitiveness. Analysis of different designs of the Kryvyi Rodina mine power system reveals that mini pumped storage hydroelectric power plants are efficient when generated capacity is close to the installed capacity of consumers. The system with mini PSHPP for storage pumps and hydrogenerators on the 500 meters and 940 meters levels appears to the best option for the peak tariff, as it reveals the lowest value of the NPV in conditions close to nominal and highest application area. However, the analysis of NPV indicates that under conditions close to nominal, the use of the mini PSHPPs with single hydroturbine has the highest reduced cost due to low generation, thus make it inexpensive to use compared to other designs. With the basic tariff, it's advisable to use the distributed generation system with only 2 storage pumps installed on the 500 meters levels and has the highest efficiency among all study design. Thus, the greatest economic effect can be achieved by introducing mini PSHPP system consisting of 4 hydroturbines, 2 of which are used during the basic tariff hours. When the peak tariff is used, all units are involved. Such balancing should be introduced by means of the power supply control system of mine consumers. Thank you for your attention.